Welcome back to The Explainer. Have you ever wondered why automated legal contracts sometimes just fail spectacularly? Today, we're diving into the literal hidden mechanics behind modern legal technology. We're going to unpack exactly why your standard, everyday word processor is actually failing the future of law, and why strict, structured formatting is the absolute ultimate universal interface between human intent and machine execution.
Okay, let's just jump right into this by asking a totally meta question about how humans and computers process legal truth. When we interact with digital laws or automated contracts today, are we just getting this clever illusion cooked up by AI, or is there a rigid, exact truth running underneath the whole thing, making sure every single rule is perfectly enforced? To figure that out, we really have to look at this fascinating conflict happening at the very core of modern computing.
So, here is our roadmap for this explainer. We'll start with the modality gap, look at the DOCX semantic gap, introduce Akoma and Toso, and then break down the FRBR hierarchy, temporal tracking, and finally, the future of law. Let's get to it. Section 1. The modality gap, probabilistic AI versus deterministic hardware.
Think about the massive divide sitting right at the heart of modern computing. On one hand, you've got modern AI. It processes language in these messy, continuous webs of association. It's stochastic, meaning it basically plays the odds, which is exactly why it sometimes just hallucinates facts out of totally thin air. But then, on the flip side, you have the literal, rigid reality of your computer's arithmetic logic unit, or ALU. Built in silicon, this hardware runs on discrete math and it demands absolute, perfect exactness. Bridging that huge gap between the continuous messy thoughts of humans and the rigid execution of a machine is incredibly difficult.
Which brings us to Section 2, the DOCX semantic gap, the illusion of visual structure. We pretty much all use Microsoft Word to draft rules, right? DOCX is the dominant format everywhere. But here's the kicker. A DOCX file is essentially just a painting of a house, not the actual architectural blueprints. To you and me, bold text and numbered paragraphs look like a highly formal, legally binding section of a statute. But to a machine, it is completely blind to that. Without a semantic XML layer running underneath, that bolded paragraph is just a random string of meaningless letters. The visual presentation gives us this totally false illusion of structure, leaving the machine totally unaware of what the text actually means.
So what actually happens when we try to automate or scale up systems that lack that deterministic structural fidelity? Well, we end up with massive legal minefields. A perfect example is the patent thicket crisis. Just let this number sink in for a second. 250,000. That is the estimated number of active overlapping patents covering just one single modern smartphone. Because unstructured DOCX files can't be easily parsed or cross-referenced by machines, we get these incredibly dense webs of overlapping rules. It completely stifles R&D and creates what scholars call moral crumple zones, situations where the sheer complexity of the machine obscures responsibility and humans are basically left to absorb all the damage.
So we definitely need a fix. Section 3. Enter Akoma and Toso, Legal Doc ML and the semantic web. To solve all this chaos, the global legal technology sector realized they desperately needed a deterministic standard. So they turned to this framework, Akoma and Toso, which actually translates to linked hearts in the Akan language. Today, it is an international OASIS standard officially known as LegalDoc-ML. It was originally developed with UN funding to interconnect parliamentary documents across Africa, and now it's basically the global baseline. The brilliant thing here is that Akoma and Toso completely replaces messy, visually oriented word processing with highly structured, actionable, machine-readable XML data. We are finally handing the machine its architectural blueprints.
If you really want to grasp how this works, think of Akoma and Toso like a perfectly organized family tree. It represents legal texts as document object models, or DOMs. By mapping the intrinsic hierarchies of a law, the chapters, the articles, the specific subsections, directly onto the branches of this tree, we enable some seriously incredible things. We can build interactive legislative editors, fully automated compliance systems, and even self-executing computable contracts. We take static, dead prose and transform it into live, actionable data that hardware can safely execute.
Section 4. The FRBR hierarchy, abstracting the legal document.
To make these structured documents universally accessible, the whole system relies on a very specific functional naming convention called the FRBR model. That stands for Functional Requirements for Bibliographic Records. It's basically a step-by-step conceptual ladder that categorizes a legal resource into three totally distinct levels. First up, you have the work. That's the raw, abstract idea of the law itself, totally independent of any language. Second is the expression. That's the same law translated into, say, French, or maybe the specific updated version from 2024. And third, you have the manifestation, the actual physical or digital format, like the XML file itself or the PDF you just downloaded. This exact hierarchy allows Akomontoso to map resources into globally resolvable URIs, guaranteeing absolute precision whenever we reference digital laws.
Section 5. Precision and temporal tracking. The atomic level of identifiers.
If we really want to enforce strict hardware fidelity out in the real world, we have to zoom way, way down to the atomic level of the document. Every single provision in an Akomontoso document gets tagged with these deep addressability attributes. First is the EID. That provides the logical physical location like Section 3. But wait, what if a new law passes and the whole document gets renumbered? Well, that physical location changes, right? And that is exactly where the WID comes in. The WID acts like a permanent tracking beacon, bolted onto that specific block of text, keeping a static identifier no matter where that text gets moved or renumbered in the future. And finally, the GIDID ensures absolute perfect uniqueness across every database. Together, these identifiers ensure that downstream automation engines can interact with even the tiniest subprovisions completely safely and predictably. And honestly, this level of tracking is absolutely vital. Noam Chomsky actually hit the nail on the head regarding the modality gap when he said, "Unlike the human mind, current large language models totally lack non-sequential planning. Because at their core, AI models are just probabilistic pattern matchers. They suffer from the illusion of memory. But that static wide attribute we just talked about, it creates actual, permanent digital memory for our legal records. It tracks the workflow, the versioning, the entire procedural life of a law over time, and that stops our foundational legal truths from just degrading into inaccessible statistical noise."
Which brings us to our final stop, Section 6, the future of law, executing the divine script. Let's step back and look at what this entire synthesis of semantic XML structures really means for how we govern ourselves. Structured imperative text is essentially the ultimate universal interface. It acts as this semiotic bridge between messy human imagination and exact computer action. By using precise XML frameworks like Akomontoso, we're making absolutely sure that our collective legal intent is embedded directly and safely into the physical behavior of silicon processors. We aren't just crossing our fingers and hoping an AI guesses what a law means. We are formalizing it computationally. We are literally building laws that hardware can execute flawlessly.
So here is the ultimate question to leave you with. As the stewards of these machines, the choice of how we author and formalize our rules is entirely up to us. Are we going to keep relying on visual presentation tools like DOCX that leave machines completely blind? Are we going to settle for unpredictable statistical engines guessing at our messy data? Or are we going to do the hard work of semantic engineering? Are we going to actively wield structured text to build true deterministic fidelity right into the core of our legal systems? Definitely something to think about. Thank you so much for joining me on this explainer, and I'll catch you next time as we keep unpacking the hidden systems running our world.